Between the peak of Roman concrete in the Pantheon and this later garden example that I gave you in the last section of this lecture, which happened in the early 20th century, concrete really had a lull. Not much was happening with concrete, again, because as you've seen in these videos, it is great under compression, but it's terrible in tension. So not a lot could be done, contrary to the example of the Pantheon, without an immense amount of engineering skill and labor. Between the early Roman use of concrete and the modern brutalist architecture that we'll look at later this week, concrete sat visually dormant for centuries, seen only in slabs and low horizontal structures, and used behind other materials, as we saw, like brick, for support. It wasn't until the invention of reinforced concrete, an invention that came about due to the hard work of multiple people who have not really been acknowledged in the history of architecture and concrete construction, that we now see concrete everywhere, from bridges to large, massive, often state buildings. Concrete is the ubiquitous material of the 20th century and into the 21st century. I posted a video for you just before this as to just how concrete is reinforced and the way that that metal gridded structure within the poured concrete itself adds the tensile strength that concrete's missing. Now that you have the engineering and the technique and understanding of the technique behind you from that previous video, let's look into the ways that architectural innovation took advantage of this newfound way of using an age-old material. We'll begin with Robert Maillard, a Swiss engineer who revolutionized the use of reinforced concrete. Take a minute to look at this bridge. Jot down some notes, either to email me or in the Slack discussion forum, about what you think when you see this. One of the things that might stand out is the fact that we've just discussed the way that concrete is great in compression, meaning when it's pressed down, when something is weighing it from the top, it is a very strong material. But in tension, usually in circumstances like this bridge spanning a valley, it would be horrific. It would crack in a million different places. But just the addition of metal reinforcements transformed bridge architecture from something that had to be done in steel to something that more often than not is now done with concrete. This bridge was constructed in 1930. It is as modern and as gripping as anything designed today. The span between nature and human culture, between the slow processes of the trees, the mountains, the stones there, and the fast-moving pace of human transportation really come together in this beautifully designed work by Maillard. Another way that reinforced concrete improved the use, the ubiquity, and the elegance of this material is in what we see now as these mushroom slabs. It's not unlike the pier and lintel structure, right? We have the piers in the form of these tall columns that splay out at the top with a fan-like shape to support a concrete roof above. But that concrete roof requires reinforcement, or again, it would crack all over the place because concrete just isn't good by itself in tension. But distributing reinforced concrete throughout the span of the roof, even steel I-beams that move through there to give that plane, that second floor or third floor ceiling / floor for the people above, strength, transforms what this mundane material can do. Auguste Piret takes concrete to a new height. He is a French architect and a pioneer in the use of reinforced concrete. Let's look at just what sets him apart. Perret and his family were the first to propose the use of concrete in housing structures. And they did it on one of the most posh, fancy streets of Paris, the Rue Benjamin Franklin, oddly named. So it was in this apartment building that Perret established his reputation to be, as he is now, regarded as one of the canonical concrete architects. And this building being one of the canonical works of concrete architecture of the 20th century. Not only for its explicit and brilliant use of reinforced concrete in the structure, in the frame, which is known as the Hennebick system. You won't need to know the Hennebick system, but just FYI. But also for the way in which its internal organization anticipated later developments, which we'll see in the international style section later this week. What am I talking about? First, take a moment to jot down some notes about what you see in the image on the left. Again, email these to me or put them in Slack. In many ways, we've seen this facade before, right? It's a 3-part or tripartite facade, not uncommon in Art Deco structures. It consists of at least 8 or 9 stories, that bottom story being greater in height than the rest of the stories. And we can imagine that inside this building are a series of apartment homes or condos. And those condos have an array of windows with terrific views, right? Some facing straight out into the street, others at an angle, to give the rooms inside a variety of light across different times of the day. Let's jump over to the plan on the right-hand side, Perret's plan. Take a minute to think about how you would move through this space. We can see the stairwell at the back as to how one would enter the apartment. In front of that stairwell, there would of course be a door into the individual apartment itself. Once one walks in, there aren't a lot of walls in this space, and the walls that are there are quite thin. Compared to any other apartment building in Paris at the time, those walls would have seemed paper thin. Because they weren't stone masonry, they didn't need to be as massive as they would otherwise have needed to be in a 9-story building. Reinforced concrete enabled an open floor plan, which we now, if you watch any HGTV or any design show, everyone wants an open plan. And what that means is you can look from one room to the next without a lot of small walls in between. Perret's building at Rue Benjamin Franklin is really the first step toward that open plan, as you can see from what we're looking at here. When Perret and his family, who were a group of engineers, sought funding for this building, no one would back him. No one wanted to see concrete in any form on the Rue Benjamin Franklin, and they thought it would be a horrible, horrible eyesore. To really combat them, Perret's family themselves raised their own funds to invest in this building. They wanted to show the world what modern reinforced concrete could do. And to overcome that obstacle of the idea that concrete was unsightly, we can see what they did in the center image. Look at it carefully. What's going on? It's all concrete. Those bits that look like stone end caps, that's formed concrete. Those flowers, those with their beautiful, delicate leaves, that's done through a process of stamp forming. And this was really a way of showing off that this building was concrete. In order to do that kind of decorative work with stone, you can imagine how many hours, how many skilled artisans it would have taken. But to be able to press a flower form, up against the side of this concrete as it was drying, Perret and his team were able to showcase not only the structural integrity of reinforced concrete, but the potential beauty in that material, setting it apart from the other buildings down the street to really announce that reinforced concrete had arrived. Perret, after the success of Rue Benjamin Franklin, success for many, hated by many as well, was invited to design one of the world's most famous theaters, the Theater of the Champs-Élysées in Paris, France. We're seeing it here in the two pictures, left and right, from slightly different angles. Think about what this architecture is hearkening back toward. What classic forms are we seeing reutilized with this hyper-modern reinforced concrete application? What tensions are being played out in Perret's concrete Art Deco design for the theater? On the one hand, Perret was still trying to push the envelope. He wanted to show that concrete could do it better, that concrete could supersede stone, could supersede any of the classical materials. But the committee who commissioned him to do the work wanted this to be an elite classical theater. And you can see the tension in the design. We have those reappearing buttresses flattened on each end of this center bit of the tripartite facade. There is even still a shocking lack of ornament for the time period. If you think back to classical Roman or Greek architecture, even the architecture we saw at Petra, each of these flat faces on the facade would have been carved to the hilt. There would have been sculpture, there would have been something everywhere, but Perret resisted. He wanted to show the beauty of the material itself. The only place he gave in is in that frieze up at the top, at least on the outside. So here we see the bas-relief of Antoine Bourdelle. It is one of the markers of Art Deco art, masterfully executed, where again we see all the themes that we discussed last time, this reappropriating of earlier, more vital cultures, the stereotype laid on top of different people from around the globe, and reappropriated to create something alluring, something so-called exotic on the facade of this famous theater. We also see that while there isn't a massive sculpture everywhere, it does exist over the box office to the left and that bas-relief in the center. Perret did use these gold and brass elements around the door as another form of ornamentation, another way of adding grandiosity to concrete. It's inside the building that he really lost control. And by that I don't mean that he went wild, I mean he lost control of the design. The traditional theater ideas took over. We see that in this gilding, we see it in these painted murals at the top. Take a minute with this mural on the right. Jot down 1 to 2 sentences about what you see. And a thought or two about how that goes well or may not go well with Perret's aims for the theater. Those murals by Maurice Denis are a replication of Dionysian themes from ancient Roman and Greek myths and stories, brought into this super modern building. It shows the tension when technology comes into play. We often, almost always, try to mask it behind the familiar, try to mask it behind historical tradition until it becomes more familiar, until we can adjust to the newness, the modernity that it's bringing along. That's all we'll do on concrete today. I've got one more video posted for you. Take a look at that, which speaks to the ecological issues with modern concrete. And you know from the readings that there are alternatives. We'll discuss those in class on Wednesday. Thanks.